Hey guys, welcome back. In this video, I'll be showing you how to build a game using Pygame. If you don't know about Pygame, it's a game library in Python that we can use to build 2D games to run on our computer. Now, in this channel, I mainly cover web development, but I figured since some of my viewers are interested in game development, this could be a useful video. So our game is going to be a very simple game since this is intended for beginners. And without further ado, I'm going to show you a demo of our game and then we can begin building it. So to show you how our game is going to work, I'm just going to run this main file that contains all the code for our game, and this tutorial.py file is the file that I'll be using to write the code for this specific video to show you guys how to build the game. So I'm just going to run the main file right now to show you what the game looks like, and if I hit enter, if I go here, you should be able to see it pop up right here, and you can see that our game has three components. It has a player block, which is green, and a enemy block, which is red. And the third component was the score in the top left. So if I run it again, you can see the score in the top left. And if we run into an enemy block, the red block right here, the game will quit, showing us that the game has concluded and that we have lost the game. And for every time that we dodge the enemy block, our score will increase by 10 points, and you can see the score increasing on the top left-hand side of the window where the score is being displayed. So now that you have seen the demo, we can get started on installing Pygame. So I have my terminal open inside VS Code, for those of you wondering, and I'm just going to type in pip3 install Pygame. Now, since I already have Pygame installed, I won't need to do this, but you can use pip3 install Pygame to install it if you are using a Mac, and if you're on Windows, you can just do pip install Pygame. And since like I said, I already have it installed, there's no need for me to install it, but if you don't, those are the commands that you should use. And once you have the installations done, we can begin setting up our game window. So to begin setting it up, we're going to need to first import a few things. So I'm going to do import Pygame to import the Pygame library, and then I'm also going to import random, which is going to be used to generate random expositions on the screen in which the enemy block will fall from. If you saw the demo, you would notice that the enemy block was falling randomly from a position on the screen each time that it was generated. So after we've imported random, we're just going to do pygame.init to initialize all of the imported Pygame modules, and then we're going to set up some configuration for our game window. So for our game window, I'm going to give it a width and height of 800 and 600 respectively. So there you go. You can use these commas, and this width will correspond to 800, and then this height will correspond to 600 right here. All right. And I have these capitalized since these are constant variables, and constant variables are any variables that you're not going to be changing in your code. Alright, and next I'm going to create a game window for our game. So to do this, I'm just going to call this variable win. And again, this is also a constant since we're not going to be changing our game window. So I'm going to go ahead and set this up by doing pygame.display.set_mode. And then we're going to pass in a tuple, and this tuple is going to consist of the width and the height, and this will create a game window that is 800 pixels wide and 600 pixels tall. Next, we're going to need to create a title for our game, and if you don't know what a title is, it's basically this right here. So if I show you this title in VS Code, you can see that it says tutorial.py Pygame. That's basically the title for a window. So for our game specifically, we can just do pygame.display.set_caption, and I'm just going to call it first game for the sake of this video. And next I'm going to create a main game loop, which will be our loop in which the game runs. And if you know anything about game development, games will have a main loop that listens for any events that happen on the screen. And to do this, I'm going to create a main function that will have everything our game needs. So I'm going to first write the function, and I'll explain to you what it means. So I'll go ahead and do define main, and I'm going to create a game running variable set to true by default, and then while the game is running, we're going to listen for any events that occur within Pygame. So for event in pygame.event.get. If the type of event, by doing event.type, is equal to pygame.quit, then we're going to set this game running variable to false, quit the Pygame window, and break out of this while loop to prevent any further processes from running, and I'm just going to call this main function in the end. So here we have a game running variable that is set to true by default, which will happen when the window shows up. And while the game is running, we are looking for any events that occur in Pygame with this for loop right here. So for event in pygame.event.get, which is going to return a list. We're going to check for the type of event that occurs, and if the type of event is equal to quit, which means that the user wants to quit the window, then we'll set this game running variable to be false since the game is not running anymore. Then we're going to quit the window and then break out of this while loop to prevent any further processes from running. And lastly, we're going to simply call this main function, and calling this main function is crucial since this is what makes the window appear in the first place. So I'm going to go ahead and run this code by doing python3 tutorial.py. If you're on Windows, you're just going to do python tutorial.py, but since I'm using Mac, I'm just going to do python3 tutorial.py. If I hit enter and if I go here, you can see that the game window pops up right here. Now if I click this X button right here, it's going to trigger this pygame.quit event, and if that is the event that has occurred, then we're just going to quit out of the Pygame window and break out of this while loop to prevent any further processes. Now if I were to comment this main function call right here and not call this main function at all, what would happen is that the window would only appear for a split second, or it doesn't even appear at all actually. It'll only run the script, but the window won't pop up since we don't have this main game loop running. So make sure that you have the main function called so that the game can actually run. And if I show you again, you can see that we have the window with an 800 pixel width and a 600 pixel height, and the title of it is set to first game right here. If I just click this X or hit Command Q, it quits the window as we expect it to, since the event type is equal to quit. Now that we have the window set up, we can begin creating our player and enemy blocks. And since the player and enemy blocks are very similar, and the only differences are really just in width and height and a little bit of the speed, we can create a class that we can generate both the player and enemy blocks from to simplify a lot of things. So if you don't know about object-oriented programming, I would definitely recommend looking into it after this video, but just to give you a basis, we're going to be creating a class that will create an object, and we can use the __init__ function to construct our own object with a specific x and y coordinate with height, speed, as well as the color to create both the player and enemy block. So I'm going to start by doing class block to initialize the class, and then I'm going to do define __init__, and I'm going to pass in self. And this self keyword you're going to have to pass in for any method that you write inside of this class, since it's going to be referring to the object itself. And for our blocks, we're going to need the x and y position. We're also going to need a width, a height, a speed, and a color, which will be passed in as a tuple. So now I'm just going to do self.x is going to be equal to the x value that's passed in, self.y is equal to y, self.width is equal to width, self.height is equal to height, self.speed is equal to speed, self.color is equal to color. And what this will do is basically define these variables that are prefixed with the self keyword, which refers to the object itself. It's going to set their x, y, width, height, speed, and color to whatever we pass in whenever creating this object. And the object itself is going to be the blocks that we have on the screen, which is the player and enemy block. Alright, and next we're going to need a way to draw these blocks onto the screen, so I'm just going to create a method called draw. And again, like I said, we're going to have to pass in the self keyword. And what we're going to do is return a rectangle object that is created by Pygame. So to do this, we can just do pygame.draw.rect. And we're going to draw this on our game window, which we've defined over here. And this rectangle is going to need a color. So for the color value, we can just do self.color, and we're going to have the x, y, width, and height in this third argument. So to pass it in, we can just do self.x, comma, self.y, self.width, and self.height. And what this will do is create a rectangle on our game window with a specific color that we pass in, with the given x and y coordinates along with the width and height in pixels, and draw that rectangle onto the screen. So you'll understand more of this once I actually draw it onto the screen, but for right now this is all that we need. And additionally, we're also going to need to initialize a few colors in our game. So if you didn't know, or if you remember properly, the color of the enemy block was red, so we're going to have the red color value in RGB, since that's what Pygame is compatible with. So red is going to be set to 25500, and this is just some RGB values, so red, green, and blue, and we go all the way up to 255, which is the max for red, and then we have 0, 0 for green and blue. Alright, it's a bit more complicated, but just follow along and you'll understand. And our background color was set to black. So for black, we can just do 0, 0, 0, and this will create a black background color. And then our player color was green, so we'll do 0, 255, 0, since the red value is 0, green value is all of it, and the blue value is 0. And then our score was displayed using white. So we'll just have white and 255, 255, 255. And if you mix all of those together with the max value, you'll get white. So after this, we're just going to go ahead into our main function, and we're going to create a player block. Now, to create the player block, we want the player to be in the middle of the screen by default. And there are a few other things that we're also going to need, like the player height, the width, the x position, and the y position, which is going to be in the middle of the screen along with the speed. So let's go ahead and start by defining those values. So we want our player's height to be 40 pixels and their width to be 40 pixels since they are a square. Now the x position of the player has to be exactly in the center of the screen, and to correctly pinpoint that, we can just take the width of the window, which we've defined above here as 800, floor divided by 2 so that we get the exact center, but also optimize it so that our player's width fits in properly with it. So for that, we can just subtract the player's width by doing player width and then divide that by 2 so that we have the exact center of the square at the center of the screen. Then we're going to do the same thing for y, so I'm just going to copy this code, paste it here. Instead of having width, we'll just do height. Instead of having player x, we'll do player y. Okay? And this will be the x and y positions for our player, and it will be in the exact center of the screen. And next, we're going to need the speed of the player. And for our player, let's just give it a speed of 15, which is the amount of pixels that it will slide to the left and right by, depending on which arrow key that we press. Okay? And next, we're going to need to draw our player block. So to draw this player block, all we're going to need to do is create an instance of this class. And what's cool about classes is that you can create many instances of the same thing and also delete those instances in Pygame as well. So to create our player, we can just do player is equal to block, since we're going to be creating a player using this block class right here. And we're going to pass in the x position, which we've defined as x here, y, width, height, speed, and color. So to do this, we can just pass in these values that we've written down just now. So for the x, we'll just do player x. Y, we're going to do player y. Width, player width. Height is going to be player height. And the speed will just be player speed. And now that we have the player created, we just need to draw it. And to draw it, we'll just be calling this method that will return a rectangle object with the values of our player. Now, additionally, we also need the player color. So for the color of our player, we need the green. So we'll just pass in this green variable, and if I do green, green will be passed in as the color, and that will be set to the color here, which is going to be drawn. And then inside of our main loop, we can just go ahead and draw our player by doing player.draw. Now if I run my code and go over here, you'll see that our window is going to pop up, but we don't have the player in the center. And the reason for that is because we haven't updated our game window. Now to update our game window, all that we need to do is pygame.display.update. And this will update all the parts of our window and draw everything that we need. So if we go ahead and do python 3 tutorial.py, you can see that our player block is drawn, but there is something wrong with our Y position. It is perfectly in the center, but it is not in the center of the Y axis. So to fix that, it's probably some typo that we made, and it is. So for our Y position, we had to change this width to height. That was a mistake that I did when copying and pasting. So if we do tutorial.py again, you can see that our player is directly in the center of our screen. Now next, we're going to need a way to move our player block. And we're not just going to go ahead and create the enemy just yet. We're going to first make sure that our player can be mobile. So we're going to create a move function that will allow our player to move from side to side. So to do this, we're going to create a method inside of this class called move. So define move, and then pass in self. And then we're going to get all the keys that are available in Pygame. So to do this, we can just do pygame.key.getPressed. And what this does is it gets a list of all the keys that are available in Pygame. And if we press the right arrow key, which we can access by doing if keys pygame.kwrite, which is going to check for the right arrow and it being pressed, we can just do self.x plus equals self.speed. And what this will do is move our player to the right with by a certain number of pixels, and the number of pixels is going to be equal to the player's speed, which we have passed in over here, which is set to 15. So if we need to adjust the player speed, we can just adjust this value here, and this value will directly be referencing this self.speed right here, which we can, of course, access with this self keyword. So if we do self.x plus equals self.speed, it's going to move it to the right every time that we hold down on our right arrow key. Now, what if we press the left arrow key? How would we do that? So for the left one, we can just do a simple elif, and then if the pygame dot left key, or k underscore left, which is going to indicate the left key is pressed, we're just going to do self.x minus equals self.speed, because on the x-axis, all of your positive numbers are going to be to the right, all of your negative numbers are going to be to the left. So whenever you press the left arrow key, it's going to go to the left, since we're subtracting, and then when you press the right arrow key, it's going to go to the right since we are adding. Okay, now after this, we're going to need to call this move function to allow our player to move. So after player.draw, we can just do player.move, and what this is going to do is call the move function that will allow our player to move, and this is also going to listen for keystrokes, since it is a part of this while loop right here, which is only running if the game running variable is set to true. So if we go ahead and run our code again, and I wait for it to load, if I press the left arrow key, you can see that it's moving, but not exactly in the way that we want it. It's not moving like it was in the demo. And the reason for that is because we don't have a background color defined. Now, although our background may seem like it's already in black, the reason that we have all of these pixels going across the screen is because we don't have the background fully defined yet. And what that causes is for any movement of a sprite on the screen, it's going to cause all of their pixels to move in a certain direction, and it's going to be on top of the plain canvas instead of a proper background color. So to counter this problem and to fix it, all we need to do is fill the window with a background color of black. And to do this, we can just do win.fill black, which we've defined above right here. And if we run the code again, and if I go here, you can see that It is moving, but it's not moving quite exactly like we want it to. And the reason for this is because we have not set a FPS for our game. Now, for you guys, it may run at a different speed, and all this really depends on is the speed of your computer. Now, when we have an FPS, it's going to cap it at a certain frame per second being updated so that it's going to run the same on all computers. And typically, we usually go with 30 to 60 FPS for normal games. So we're going to need to set an FPS for our game. And to set the FPS, all that we need to do is create a clock by doing clock is equal to pygame.time.clock, I believe. Yeah, time.clock. And then we're going to create an FPS variable set to 60. And in our main loop right here, we're just going to do clock.tick at FPS so that whenever we run this game, the frames that are being updated every second is set to 60, allowing it to run the same way on all computers. If we didn't have this FPS set, it would run on the speed of that specific computer and and the FPS of that computer, and that isn't something that we want because that can cause uncontrollable gameplay like you saw just now. Now if we go ahead and run it again, you can see that it runs at 60 FPS, which is what it's capped at, and it's running at a speed of 15 pixels each time that we press the left and right arrow keys. Now if I were to increase the FPS value or decrease it, let's say if I decrease it to 30, it's going to run a lot slower because we're updating less frames per second, and it's a little bit more jittery. Now I personally prefer having it at 60. If you want to change your values, then you can do that, but for the sake of this video, I'm just going to do it at 60. So if you go ahead and run it, you can see that it is running properly. Now if you remember from the demo, the block did not go out of the window, and if we continuously press the arrow keys, you can see that it goes outside of the window, but we need a way for it to stay within the window. And to do that, it's fairly simple as well. We just go into our move function, and we're just going to define some boundaries. So let's say that the player block goes all the way to the left of the window and it's exceeding the boundary. We're going to need to set it back to the left of the window so that it doesn't exceed that point. So to check if it's exceeding, we can just do if self.x is less than 0, which is the position on the screen, meaning if the x position is 0, then stop the player from going further by setting the x value to 0. And I'm going to show you what this means in a bit. You'll kind of understand for yourself once you're on the game. So if I set it to 0 here and then run it again, and if I go all the way to the left, you can see that it does not pass this boundary. And the reason for that is because whenever the x of this block right here, this x position of this block, is less than 0, meaning it's trying to exceed where 0 is right here, it's going to stop it from doing that and reset its position to the edge of the screen. So I hope that's understandable. Sorry if this is kind of confusing if this is your first time learning Pygame, but you'll learn this as we go on. Now, we have it not being able to exceed the boundaries of the left edge, but what about the right edge? So for the right edge, it's a little bit more tricky, but I'll do my best to explain. So if I go here, and we can just do if or elif self.x is greater than the width of the screen, meaning that the x position of the block is greater than 800 minus the width of the block itself, then we're going to set the x position to the edge of the screen, because that shows that they want to go to the very edge of the screen and we don't want them to exceed it either. And you're gonna see why we have this minus self.width. So if I run the code and go all the way to the right, you can see that it does not exceed this right side boundary. And the reason that it does not exceed is because we're also, because we're resetting its position to equal to the width, but we're also subtracting the width of the screen by the width of the block itself. Because if we were not to do this right here and remove this, what would happen is that the entire block would go past. And it wouldn't go past further that, but the 800 is basically checked by the left edge of this block right here, and if that left edge is exceeding it, then we're not really seeing the block on the screen. So if we do minus self.width, it's going to allow us to make sure that the entire player block is within the boundary. And this is just some rules of the Pygame rect object. If you guys like to know more about that, then you can go ahead and check the Pygame documentation, which I'll link below. So now that we have the player block mobile and moving properly within its bounds, we can go ahead and start creating the enemy block. So for us to create our enemy block, we can create the enemy block the same way that we created our player block. So what we need is to define the enemy's height and width. So we're going to do that by enemy underscore height is equal to 50, because we want our enemy to be a little bit bigger than our player. The width is going to be 50 as well, since it's going to be a square, and the x. Now, if you remember from the demo, the enemy was falling from random points at the top of the screen. And to get a random point, what we can do is use the random library that we imported in the beginning. So to get a random x position on the x-axis, what we can do is do random.randint x minus, or random.randint, we're going to start from 0 and pick a number all the way up to 800, which is the width of our screen. So we're going to basically choose a number from 0 to 800. And we can just pass in width here. However, previously when I mentioned the boundaries for our player block and how it can't exceed the 800 width and the width needs to be subtracted so that it's still visible on the screen, we need to subtract the enemy width over here so that the enemy falls within the boundaries of the screen. And then we're going to need our enemy's Y position, and since it's falling from the very top of the screen, we're going to have it at 0. And after this, we can create our enemy object. We can do enemy is equal to block, and we're going to pass in enemy X, enemy Y, enemy width, and enemy height. Then we're going to need the enemy's speed here, which we're going to define in a bit, and we're going to pass in red as the enemy color. And for the enemy speed, we'll give it a speed of 10, just to make sure that everything is fair, since it is larger than the player. So it'd be helpful if the player has a higher speed. And this red is, of course, coming from the RGB values that we defined over here. So to display the enemy, we're going to draw them the same way that we drew the player. So we can do that by doing enemy.draw. Now, if we run our code by doing Python 3 tutorial.py, if I move my terminal a bit higher so you can see, and go back here, you can see that our enemy is drawn on a random position, and it is within the bounds of the window, and it's starting from the very top, and the position is chosen randomly. So if I refresh it or restart the program, you can see that it pops up at a different location. So now that we have the enemy being drawn, we need to make it move. So for it to fall downward to the screen and have it collide with the player, what we're going to need to do is change the enemy's Y position by however many pixels the enemy moves by. And the enemy is going to be moving at 10 pixels, so we can just do enemy.y plus equal to enemy underscore speed, which is going to allow our player, or allow our enemy to drop by its given speed. So if we run the program again, and here you can see that the enemy is falling. Now after it falls, you can see that nothing is generated again. Now how do we do this? So the way to generate a new enemy, or just to have a new enemy created and then have it fall down again after it crosses the bottom of the screen, is to check where the enemy is, right? So what we can do is write a conditional that will check if the enemy hits the ground, and if it does, then that means that the player has successfully dodged the enemy. And once they've dodged the enemy, we need to reset the enemy's X and Y position so that the enemy can fall again to make the player lose. So to do this, we can just do if enemy.y is greater than or equal to the height, meaning the height of the window, meaning if the enemy's position on the window, on the y-axis, is greater than or equal to the height of the window itself, then we're going to reset the enemy's x position. So to do this, we can just do enemy.x is equal to the same code that we wrote over here. We're just redefining it by accessing the enemy object, and then set the y to 0. And if we rerun the code, you can notice that a new enemy is falling each time they hit the ground. So next we're going to need to add collision to our game. So to add collision, it's also fairly simple. We're just going to need to do a few tweaks that will allow our game to quit if the player collides with the enemy. So earlier when we created this block class, and inside of this draw method, we were returning a pygame.draw.rect, and this is going to return a rect object. And the thing about Pygame is that if you have a rect, and if you collide with another rect, it allows you to do whatever you want, right, after colliding with the rect. And Pygame has its own method called collideRect, which will take in the rect object that we are playing with and check if it's colliding with another rect object, which in this case would be the enemy. And if it is, then we're just going to quit the game. So to make sure that this happens, what we can do is where we have player.draw and enemy.draw, these are returning a rect object. And we can store this rect object within a variable. So we can just do drawn player is equal to player.draw, which won't change anything in our code just yet. It's still going to draw the player and still going to draw the enemy the way that we have seen them drawn on the screen before, except it's going to store the return value, which is the rect object, which is this right here, within these variables, drawn enemy and drawn player. And what we're going to do is basically use the rect object to use the collideRect method, and the collideRect method will basically check whether or not the player has collided with the enemy. So to do that, we can just do if drawn player dot collideRect with the drawn enemy, then we're just going to do pygame.quit, since that would mean that the game is over. So if I run the code again and do tutorial.py, here I am just chilling in the middle. Let's say that a player hits me, or the enemy hits me. You can see that our window exited after that. So now that we have the main functions of the game working, all that we need to do is implement a way to keep track of scoring and also display the score, which I will show you how to do in the next clips. So now to keep track of scores, what we're going to need to do is create a variable called score, and we're going to set this to 0 because the user is going to first have to dodge enemies in order to actually have a proper score, right? So once we've set this to 0, we're going to need to increment the score each time the enemy has reached the ground. And if the enemy has reached the ground, that basically means that the user has successfully dodged the enemy, which would indicate that their score needs to be increased. So to do this, we can just come below line 80 right here and just do score plus equals 10, because we are incrementing the score by 10 points like you saw in the demo. And just to eliminate any confusion, I'm just going to write a comment here saying that if the enemy hits the ground, that means that the player has successfully dodged the enemy, so we need to update the score. Now, in order for the score to actually be updated, let's go ahead and run this and I'll show you what happens. So let's say that we dodge the enemy, just like you saw. But the reason that our window quit is because it says local variable score referenced before assignment. And what this means is that we're trying to change a variable in the global scope of our program within our main function. Now, you can't really change a variable that is in the global scope inside, and you can't really alter a variable inside of a function and expect that variable to change in the global scope, all right? So what we need to do is define the score variable as a global variable. And to do that, we can just come to the top of our function and just write global score. And this will just set the score to a global variable so that the changes made to the variable in this function affect the rest of the code where the variable is used. So later on, we're going to go ahead and display the score text itself, right? And we need to be sure that whatever increment that we're updating the score variable by, the update is also accessed within that other function to display the score text itself. So basically just putting this global keyword will allow our score variable to be updated globally whenever we alter it within this function, okay? And now we can go ahead and begin displaying the score onto our screen. So to display it onto our screen, we can just do define draw score, and this is going to be a function. Now for our text, in the demo, I had the font set to Comic Sans. So to set it to Comic Sans, what you can do is font is equal to pygame.font.sysfont Comic Sans, and I'm going to give it a font size of 20. And then we're going to need the actual text that is going to be displayed. So for the actual text, we're just going to display score, colon, and then the score itself. So we can just do font.render, and this is going to take in a string. And what we're going to do is I'm going to do an f string. And if you don't know about f strings, it's basically when you can pass in a variable into a string by using this f at the beginning of the string. So I'm going to do f score, and then here I'll just do score. And then for the anti-aliasing, I'm going to set it to true to make it look nicer. And we're going to give it a color of white, which of course we are referencing to this RGB value right here. And once we have this done, we can just create this text into a rect object by doing text underscore rect is equal to text.getRect so that we can display it onto our screen as a rectangle. And then we're going to do text underscore rect dot center. And we'll just do text rect dot width and 10, and this will just be the coordinates. So our x position of the score itself is going to be however long the width of the text rect is, and 10 will just be where we're displaying it on the y-axis. Next, we're going to need a way to display it onto our window, and our window is just win, which we are referencing over here, and this is just going to be the surface that we're drawing this score on top of. And to draw it on top of our window, we can just do blit. And here we're going to pass in our text and the destination, which is going to be our coordinates. And those coordinates are stored within this text rect variable. So now that we have this, we just need to go ahead and call the function. So I'll just call this function right here above player.move on line 100. So now if I go ahead and run my code, you can see, well, I died right there, but let's run it again. You can see that each time that the enemy reaches the ground, or each time that the player dodges the enemy when it's falling from the top of the screen, the score is incrementing by 10 points like we need it to, and the text is being displayed properly. So if I go to the very edge of the screen, you can see that our player is not going out of it, and our enemy block was falling within those same boundaries, and each time, or whenever the enemy block hit the player block, the window would quit like we expect it to. Alright guys, that's it for this video. I apologize if I may have not explained certain things as well, or if you found this a bit rushed since this is my first time teaching Pygame, but if you experience any confusion or have any comments, please leave them down below in the comments section and I will do my best to simplify things for you. Other than that, I hope this video was informative and you were able to learn something, and if that's the case, then leave a like and subscribe to the channel. If you're new to Pygame, congratulations on building a functioning game with it, and if you're interested, the code in this video will be available on GitHub once this video goes live, so if you need to reference it, feel free to do so. Thanks so much for watching, and as always, have a nice one.